Brad, I love it when technology's fun.
Yeah, that's nice as opposed to the alternatives, which are many.
I mean, look, there's a lot of alternatives, when Ring camera is like, hey, man, we can, turn over your footage to help people find lost dogs and also, help ICE. That's bad. But, sometimes technology is good. I was watching the Olympics. I like to see how things change every 4 years. And, the Winter Olympics are always good because it's, it's the death sport Olympics, not the who can go faster and jump higher Olympics.
Going faster and jumping higher can also be a death sport.
I mean,
for what it's worth, but
fair. But one of the things that's happened over the last 2 or 3 Olympics is that drones have gotten real good. So, we used to cover drones over at Tested, and I've spent a fair amount of time with them over the years. And they started out as a thing that people would use instead of boom shots. So they'd use them instead of crane shots and stuff like that were relatively static. I want you to watch this video I just sent over. It is footage of people barreling down the mountain at 100 kilometers an hour in the Alpine downhill, the death sportiest of snow skiing races, I think. And they have little micro drones that have really good 4K cameras. The video quality on this particular one is bad. When you watch it on the broadcast, it looks fabulous. Of the drones just tracking the racers as they're going 100 kilometers an hour down the hill. And it's kind of incredible. They're using them all over the place. I was watching the luge yesterday, and the drone operators are flying the drones down the luge track just behind the racers. So you get an over-the-shoulder third-person video game view of people going the luge track at 100 miles an hour.
Do you think this is definitely human operated? It's not some kind of computer vision motion tracking, image tracking thing?
So I don't know for sure. So, that's definitely a technology that exists. You can buy drones that will throw up in the air when you're going skiing, and they'll track you on the way down the mountain. I kind of assume that's the case for the luge track. Watching the mistakes that happen on the downhill, I think it's probably not, because I think they pick up they catch them on the way over the ridge when the drone would take a minute to acquire them. And I think they're at least human operated for part of it.
Sure. I believe that.
It's wild and it's very cool, and it made me happy, and it's been fun because last time they weren't doing this, and the footage from the drones looked crappy, and the drones advancing, the cameras advancing. It's all good, man.
I want to see a drone for the drone.
You want a drone operator drone?
Yeah, I mean, I'm kind of sort of take or leave the winter sports stuff, but I would absolutely love to see the drone in action. I want to see how micro is micro here when we're talking about a micro drone.
So from what I've seen in the other shots, because when they're doing the head-on shots, you sometimes catch the drone behind it. It looks like they're 250 millimeter drones.
Wait, that's wow.
Well, no. It's they're the size of a shoebox, basically.
But that's still way. I thought we might be talking the size of a dog. I don't know why a dog is my size reference here, but something the size of a coffee table or something that's way smaller than I expected.
They're definitely using micro cameras, GoPro style size cameras or DJI style cameras. They're definitely not big giant octo quads. You can hear them, and they sound like little mosquitoes, which usually means smaller propellers going faster. But yeah, these are the ones. My hunch, and I haven't found a tech article explaining how they're doing it yet, because drones are boring now and people don't write about that anymore. I haven't found an article talking about the drone pilots and the drones. But my hunch is that they're the racing class that we used to go to industrial sites in South City to watch people zoop through pipes and broken windows and shit like that in abandoned warehouses.
Yeah, I didn't watch the Super Bowl this year, but we talked about it on the Ramblecast this week, and I meant to ask Vinny and Alex and did not think to if there were any kind of obvious drone shots at that.
They had drone shots in the halftime show. They definitely do some drone shots of the outside of the stadium and stuff like that. I didn't notice they used that spider cam in all the major stadiums now.
That's the thing that's on a tether though, right? Like a zip line.
Well, it's on it's tethered to corners to the the corners of the field, basically at the top of the stadium.
Still physically connected to something though.
Yeah.
As opposed to flying, because independently flying cameras buzzing around at a sports game is that's not even some future shit. That's some Star Wars shit.
Yeah, kind of, right?
And yet it's just here. The only difference is that we are using typical rotor. What's the term? No
repulsor lifts.
Rotor lifts, not whatever the hell a repulsor lift is. So we're not quite there yet, but it's effectively the same thing.
But yeah, it's and it's funny because they're not filtering out the noise of the drones from the broadcast, which I was surprised by, because that would be pretty easy to pull out, I think.
Yeah, sort of.
But no, you just hear the drones buzzing, which is kind of how you know that a drone shot's coming. It's nice.
The future is here.
Unevenly distributed.
Sometimes it's cool.
Welcome to Brad and Will Made a Tech Pod. I'm Will.
I am Brad.
Brad, it's early in the morning. I am a sleepy boy.
As it often is around these parts. So by these parts, I mean this podcast.
It's true. This is a morning pod. Like, I've always wanted to have an evening podcast. I've never had an evening podcast before.
No, thank you.
Okay, I think I
am out of words by the evening.
I've often thought it would be fun. Like, I used to love doing the late night PUBG streams and watching how weird everybody gets at about 11 o'clock at night.
Oh, sure. Like a stream, a video game stream, totally fine. You can get sloppy. And I don't mean sloppy in like inebriated sense, but you can just kind of be a mess on a video game stream and it's fine.
I think doing like an Art Bell style call-in show, like take Art Bell and Car Talk and mash them up into computer help.
Yeah.
And I would like to do that show late at night.
That might be fine. I don't know.
When people are having their computer problems. Because computer problems, I find, almost always come at night.
Yeah. This is a yes, you're not wrong. This is a pretty technical show though. I like the mental sharpness and clarity of the early morning recording as opposed to the very end of day or evening recording.
That's true. So it's funny you say that though, because there's a couple of like daily games that I play every day. One of, I can't believe I'm going to say this, but one of the favorite ones is actually on LinkedIn. It's like a Sudoku chess puzzle, basically. And they time you and tell you how you do versus your average and versus people on your leaderboard. I always do better if I do it at like 11 o'clock at night than at 7 o'clock in the morning.
Weird.
Always.
Weird.
Yeah.
I'm in bed before that at this point.
Yeah, you see, we're both insomniacs at this point, but we're on opposite ends because I can't go to sleep and you wake up early, I think.
No, my brand of insomnia is I fall asleep in 5 minutes or less, but then can't sleep more than like 6 hours at the outside. It's a staying asleep problem.
I've been reading so many books in a way that I haven't really since the start of the pandemic. So that's nice, at least.
Yes. Okay, real quick, before we have a topic this week, but before we get into it, I have a question for you. Speaking of computer problems and late night.
Yeah.
And this is also a question that ultimately I'm going to put to our audience because I could use some advice potentially. Do you think it's possible? Has Windows gotten so shitty that it is now capable of eating another Windows?
I don't know what that means, Brad.
Okay, let me expand. Is Windows now practicing auto cannibalism?
Did you put a Windows inside another Windows?
Let me just set the stage. I've talked about this before. I have a second Windows install on a USB drive that is just kind of a junk install that I use for things I don't want to touch my real install.
Okay.
Like, for example, the Logitech G Hub.
Yeah.
Like shit that you know is going to hook deep into Windows that you don't want to like gum everything up.
I feel like that's less of a problem in the 21st century than it was 20 years ago. But
yeah, it's maybe not as bad as I don't. You know what? A lot of that type of vendor software is still pretty crappy.
So remember, I did the testing on this last year. We did a video about it at PC World where I took a year-old Windows install and then wiped it and then benchmarked it versus the busted old Windows install. And the performance was exactly the same. There's no performance degradation.
Yeah, it's
just jank incrustation.
And I also use that install for sketchy game mods that I might not trust, or like installing 25-year-old Windows games that may not be well behaved.
Fair. Okay.
In terms of overwriting system files or whatever.
So you're kind of using it like a VM, but it's bare metal because you're doing stuff that you require bare metal access to.
Because I would use G Hub to update the firmware on my mouse, for example, even though I have absolutely no need of any of the other G Hub functionality. Anyway, I fired up that Windows install last night to do some stuff, and it's way out of date. And I was like, I should get it on a modern Windows. I also use it I have to update the my NAS machine. Like there are some things like you can only update the Intel ME in Windows, you may know, which is a huge pain in the ass. Although actually there might be a Linux tool for that now. I'm not sure. Actually,
yeah, the Linux firmware app will do that. But also you can do that if you, on ASUS boards and certain other boards, you can just upload the zip file that has the ME and the BIOS now. and it'll do them both at the same time.
So some boards do that, some do not.
Some do not.
That workstation board
the
I've got in there
probably doesn't.
Unfortunately, the BIOS update instructions are like, please update to Windows Intel ME version blah 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 before updating this. Yeah, it sucks. Anyway, if I could get the ME update working in Linux, I might actually just toss this drive and never use it again. But anyway, I was in that dummy install, booted off this USB drive. I was like, I'll just let it Windows update to the 24H2 or whatever it wants to do right now.
Mm-hmm.
So it's, on a patched, secure, supported version of Windows. Walked away for a while, came back. The update had failed. I let it reboot. It kind of unapplied the update for 20 minutes, and then it was back to 23H2, whatever. I went to bed. I got up this morning. The Mellanox card in this machine does not work anymore.
Have you completely powered it all the way down?
This machine?
Like drained the power and everything? Like unplugged the power supply and hit the power button?
Yeah, not turning off the power supply.
I bet it got the firmware into a weird state.
So it, on the card?
Yeah. Those cards have a lot of logic on them.
I don't know about that. I had not considered that, but I don't know if that sounds likely to me. Anyway, I
can't believe I just gave you, have you considered turning it off as advice?
That might be worth a shot. Basically, I looked in event, none of my network mounts over that. That's the 40 gigabit card I use for that direct link to my NAS. None of the network mounts worked this morning, and I looked in Event Viewer, and that card was just, Windows was trying to initialize that card and failing over and over in a 5-second loop infinitely.
So my guess is you have to rebuild the external Windows drive as a, using the Windows to Go thing in order to get it to work. And I haven't been able to get it to work. I haven't been able to get Windows to Go to work with anything past 24H2.
Interesting. Okay. I had to use Rufus, the drive imaging tool. It has an option for creating a portable, an external Windows install. Here's a rub that I didn't mention. I believe this may be possible that at some point in that update process, a big Windows updates or reboots 3-4 times, right?
Yeah.
My Refind is set up to give me the boot menu, and if I don't hit any keys, boot into my regular Windows after 10 seconds. At one point in the middle of all those reboots of the external install, I wasn't around, and it booted into regular Windows instead.
So then, did it host the regular Windows too?
Could that update process have touched the regular Windows install in any way?
I don't think so.
I don't think so
for
either.
Sure.
I also don't think so. But
the way it hands stuff off during the upgrades and installs from sleep and fast boot and all that, I assume you have fast boot and all that stuff turned off in both Windowses and in the BIOS.
Oh, I don't know if fast boot's turned off on the portable Windows actually.
If it's not, that'll do it every time.
Ooh, I didn't think about that. Huh.
Yeah. Well, rebooting is supposed to always be a reboot. It's just shutdown. That's not a reboot. That's not a shutdown.
Right.
But that's so. I guess report back next week.
Yeah.
Let us know how it goes.
Yes. Broadly, the question is, can updating a second Windows on a machine with an existing first Windows fuck up the first Windows? Maybe.
I bet that the Windows upgrade got your machine, got your card in a weird state, and it hasn't been able to recover. And power cycling will do it. Well, you might have to remove the board and take it back out.
This has been multiple instances of me uninstalling it in Device Manager and letting it reinstall.
I mean physically remove it from the machine. I've had problems before that solved when I pulled the CPU and re-put the CPU in the socket. Sometimes stuff's weird.
Interesting.
Power lingers.
Yeah.
But you know what doesn't linger?
What's that?
Magnetic switches. Wait. No, they don't. Yeah, that works. Yeah, no, I'm gonna stick with that one. That's what we're here to talk about today.
Yeah.
There's been a little bit of magnetic switches have had a moment. They've been around for a really long time, but we're starting to see them in more places in keyboards and mice and stuff like that. And we thought it was a good time to talk about it. How they work, what they are, what kind of technology happens inside them, and then what it's like to actually use them a little bit on a couple of the newer devices that use them. So
you've been putting hands on a fair number of magnetic switches from the sound of things.
I have paws on keyboards and mice in the last few weeks. So lots of stuff to talk about.
Yeah, and these have been out there in, I feel like, joysticks, thumbsticks, in controllers were the first place I really started hearing about these. Hall effect and so forth. You may have heard the phrase, that's been around for several years now.
Well, Hall effect has been around. Well, Hall effect is an ancient, ancient theory. Right?
I don't mean in concept. I mean, you've been seeing them show up in actual consumer products in a way that is being promoted and is visible for a few years now. Particularly, honestly, a lot of this for most people is downstream of joystick drift on things like the Switch Joy-Cons.
That's it. So the main difference. First, we should talk about how regular switches work. So, a keyboard switch or a mouse switch typically is an enclosure that contains a couple pieces of metal. And when you push down on the switch part of the device, it buckles one of the pieces of the metal until it touches the other one. And depending on how that mechanism is constructed, they can have just a bump, they can make a noise, they can be silent and just kind of push all the way down. There's a bazillion ways to make those. And the proliferation of keyboard switches after the Cherry patent ran out has you can literally get hundreds and hundreds of different types of keyboard switches these days.
Yeah. It's just important here. It is a mechanical action that is producing a physical electrical circuit.
Yeah. And a physical contact between the two places. And that buckling that happens when you press the switch down tends to cause mechanical stress on a physical item, which will cause it to break over time.
Wait, when you say buckling,
yeah,
the metal's not bending.
Yeah,
is it every actuation?
Every activation.
It's wow.
Yeah, because you're pushing a thing down that makes the metal bend until it touches the other piece of metal.
Interesting.
Yeah.
Wait, as a design, as an intentional design choice, not as just a side effect of metal touching metal.
That is
with
not
stress on it.
No, yeah,
interesting. I didn't
anytime
realize
the metal bends, it puts stress on it.
Interesting.
Yeah. So magnetic switches use a variety of different techniques or effects to do the same thing, but with no physical electrical contacts. So like a keyboard switch that's a magnetic keyboard switch will have the same basic shape mechanism, mainly so that you can use the same kind of keycaps and they fit in the same places and they're the right stability for a keyboard. But instead of having two pieces of metal that touch each other and close a circuit, a magnet just moves up and down on the post that moves up and down through the switch. Now, this is great. There's no physical contacts to wear out. Either in the mechanism of the switch or in the space between the switch and the keyboard, right? You know, when you have those hot swappable switches, you jam the little copper wires in and they can bend or wear out or get corroded or whatever. The other benefit of this is that a lot of the stuff that was previously tied to hardware, like the actuation point for the switch, is software configurable. So you can control stuff like bounce back and actuation height, and when the switch closes, like when the mechanism stops reporting a signal, when you're lifting your finger back up off of a keyboard press, for example.
Sorry, I may have lost the thread here a little bit. How does it gauge height? It's not just a binary on off. Yes,
we'll
no.
Talk about that.
Yes, no. It has crossed the boundary. No, it has not.
Yeah, no. It's so the boundary is a software configurable thing. The way the sensors work, both Hall effect and TMR. We'll talk about what both of those are and how they work more in a minute. But yeah, they have analog signals. So like in a magnetic keyboard, if the software is set up right, is essentially an analog device that you're putting thresholds on for when the presses trigger. So, and they do that. So, I mean, let's just jump to it. With Hall effect sensors, there's a little transducer in the sensor, the thing that's mounted on the keyboard. So the sensors typically are on the keyboard. The magnets are typically on the switches because the magnets are moving. And a Hall effect sensor has a transducer that's in the integrated circuit, and the changes in magnetic flux around it change the amount of current that flows through that transducer.
Can you define what a transducer is?
It's like a little antenna, basically, for all intents and purposes. It's just a conductor that's very, very thin, so it reacts, like the current that flows through it changes. The Hall effect says that in magnetic fields, changing flux will change the amount of current that moves through a conductor.
That's how it's measuring variable gradation then in how hard you're pressing.
Yeah, so the amount of voltage that goes through it changes based on where the magnet is in the field. And so inherently it doesn't know that. Like often people use Hall effect sensors in things like RPM meters for industrial equipment or like bicycle rotation counters that give you a speedometer for your bicycle. Sometimes we'll put a Hall effect sensor up on like your back fender and a magnet on the rim of one of the rims of the bike. And then you tell it how big your tires are, and then it knows how far you're going and how fast you're going based on how many times that magnet hits the Hall effect sensor. I want to say we used them on the early MakerBots when we were building those to determine the top and the bottom of the print area, right? So anyway, but the important thing is analog signals, and you get a range, and you can calibrate them based on positioning. There's a lot of math there. especially in noisy environments like a keyboard where there's a million of these switches and a million little magnets right next to each other.
This was my biggest question about this thing, and I typed it into this doc until I saw you had addressed it elsewhere and then removed that question. But yes, it's a situation where there are upwards of 104 or 110, depending on your keyboard layout, several dozen to 100 different tiny magnets, all very tightly packed and adjacent to each other. So is there not an issue with like bleeding magnetic fields from one to the next, like signal kind of crosstalk? How does it correct for all of that?
Well, so there is, but because of the way magnets work, the field when the keys are all up is always the same, right? And then when you press down on a switch, it's the same. When you press down on the switch and the neighboring switch, that's a measurable change in the flux for both of the switches around it. And the magnets in the switches are really, really small. So the fields, their impact on the fields around them is relatively limited, as my understanding. That
was my guess, was either or both of the fields are tiny and it's not a huge problem, or they correct for it in terms of signal strength.
Well, but also, like if you change switches in your keyboard, or even I assume change switches from one spot to another, then you have to actually recalibrate the keyboard, which I haven't done yet. I assume that's just pressing a bunch of keys.
Interesting.
Yeah.
It's just a lot of quick brown fox type stuff for a while until it's happy.
I don't know. You want me to try it?
Sure.
What could go wrong? I didn't think to do that. So anyway, but the point is, because it's analog, you can control things like actuation height and like when the key press lets off, like when you're lifting your finger back up. So the activation height and the release height don't have to be the same in one of these mechanical keyboards. If that makes sense.
Yes. It's on at a higher height than it lets off of, is what you're saying.
Exactly.
Or vice versa. I guess you could set it either way.
So when I do a calibration, I'm calibrating my E switch right now. I press the selected key on the physical keyboard all the way down, and then I press the start button, and it just says, oh, it's calibrated. So there's nothing it's just looking for which sensors detect flux change, or what the sensor underneath it detects when it changes.
All right. Well, we'll get into more of the hands-on toward the end.
Yeah.
For this specific keyboard you're testing.
So, okay. So there's also this other thing that you hear about in the game, in the Joy-Con drift world, which are TMR sensors. That's short for tunnel magnetoresistance. Yeah.
The first place I saw this was, I think it's like 8BitDo's last couple of controllers.
Yeah, they're ultimate Bluetooth 2s, I think, are both TMR sticks.
They're starting to move to TMR instead of Hall, and they definitely, but of course they do kind of talk it up as these are better than Hall. This is the next generation of this thing. I don't know how accurate that is, but
so that's accurate. That's fair. This is a newer effect that was discovered in the 70s versus the 19th century, I guess 1800s. And they use less power. They measure the change in resistance of a thin insulator between two ferromagnets on an integrated circuit. So imagine two magnets with something that insulates between them. And the tunneling TMR effect, the tunneling magnetoresistance effect, says that in a magnetic flux field, electrons will tunnel across that insulator and into the other, from one magnet to another. And that's a measurable effect, because you can measure the resistance of that insulator.
Yeah. Speaking of measurable effects, I'm sure you don't have numbers in front of you, but I wonder if the savings in electricity required to drive these is meaningful across, again, somewhere between 60 and 100 switches on a, especially if it's a wired keyboard, doesn't matter. But like I use a wireless keyboard, and I wonder if that many switches makes a meaningful difference to battery life to have TMR overhaul.
From what I can tell, it matters much more on small integrated circuits that are being used on smaller batteries. The batteries in mice and keyboards are relatively large.
Yeah. So fair.
So the bigger thing is that they're faster and more more precise than the Hall effect sensors generally.
Faster, more precise, and less power is a pretty compelling combo. Although,
and they're quantum. So they use a quantum effect. The tunneling can't be described in classical physics. It's only a quantum effect. So using quantum mechanics would use TMR sticks.
So these are quantumly entangled keyboard switches?
I don't know how entangled they are, but it was very clear. The articles I read about this all described this as quantum effects. And I went and looked at it, and I dug in further, and I was like, oh, right. Electrons jumping. Yeah, that is quantum.
Okay, that's not entanglement. If it's one particle moving as opposed to two different particles and influencing each other at a bizarre distance, then that's not. Ask me anything about quantum mechanics. Anyway.
But so the TMR effect is the same thing that's been in modern hard drive heads for like 15 years at this point. The ones that float above the surface of the disk on a cushion of air. So yeah, the switches measure the change. The physical setup for these switches is the same. The sensors on the board, the magnets on the switch. The switch measures the change in resistance in that insulator, which is faster and, like I said, uses less power and more precise.
When you say faster, are we talking on the order of nanoseconds?
I don't know.
Microseconds?
I couldn't find that answer. I looked for that, and I think it's not on a human scale faster.
Right.
Was my read. Probably milliseconds versus microseconds, or milliseconds versus nanoseconds, something like that.
I mean, at the same time, you're seeing esports pros now talk about wanting 600 hertz monitors and things like that, or you straight up see people talking like they can't be competitive at lower than 480 hertz or some insane
I want to
threshold.
say there was a Counter-Strike tournament that was sponsored by Intel, and everybody's really raw because they put mid-range CPUs into it.
Yep.
So the machines were only getting 180, 200 frames a second.
Yeah.
Now the problem with the TMR sticks is the sensors are relatively new. The IC sensors are relatively new. That means they're more expensive. So when I was looking at like replacement sticks for a DualSense, for example, which you can buy on Amazon, 4-pack of 4 Hall effect sensors was $12. I have a 4-pack written here, but it's a 2-pack of TMR sticks was $20. So
okay, so
they're significantly more expensive.
That's what, $3 versus 10 a stick.
Yeah, basically.
I was going to ask something else. This is mostly relevant in the context of a DualSense. Are those sticks and the circuit board integrated together, or is that just the stick? Because on a DualSense, you have to solder if you don't have that whole contraption, I believe.
So this was to desolder. These were units that would desolder the old sticks and resolder on the new sticks. So but you'd replace the stems and the caps from your board. I think
that's pretty substantial then, as opposed to Joy-Cons that just use easily inserted ribbon cables. Like the stick replacement on Joy-Cons is pretty dead simple as these things go. But
yeah, so we should talk about why. Like in the old days, thumbsticks and joysticks used potentiometers, which are like sensors that measured the bend of a material inside the change the resistance based on the bend of a physical material. Usually there were a bunch of other ways that they could do that, but that was the more common one. Modern thumbsticks in like the Switch and the DualSense have 2 touch surfaces. They have a mechanism in there that has that pivots on both axes, and it moves these they're like little virtual thumbs basically that move on a little touch surface back and forth on a linear way on the X and Y axes. And those pushers push down on these touch surfaces, and that's what detects the movement, those touch surfaces. Because, hey, this is weird, but touch surfaces are very inexpensive to make now.
Yeah. Weird. Guess what else? They also wear out as they grind against each other over time.
Well, so they do wear out when they grind against each other over time. In the Switch's case, it was more often that dust and particulate got into there and got stuck on that touch surface and would interfere with the touching part of it. And then the software couldn't cope with that once it got beyond a certain level of dirtiness. Yeah.
That's speaking of, I don't know if this is the time to say this, speaking of software coping with physical effects, physical anomalies.
Yeah. I mean, I think let's the fact that the shorting out was a problem is what started this whole conversation about magnetic switches, I think, in a lot of things. But yeah, so let's talk about software fixing your other problems.
Yeah, like my first question about these when we were putting these notes together is, do magnetic switches fix debouncing, which is a phenomenon I have become acquainted with on this podcast over the last couple months as my relatively inexpensive but decent Keychron started registering a whole bunch of extra inputs.
Yeah.
And then as I talked about recently, I updated the firmware on it thinking that would not do anything. And then in fact, it did everything in the sense that they tweaked the debouncing algorithm in this thing. So
the bouncing happens because the connections aren't perfect, right?
Yeah. The short version. So I looked it up, and from what I read, the short version is that yes, these do basically eliminate the bouncing effect. But yes, when you are slamming 2 pieces of metal together with a decent amount of force, I assume it's everything from the amount of force you're applying to like tiny variations in the shape of the metal. And it's just the impact. It's just the impact.
Yeah, I was going to say on the hard impacts, especially if you're a hard typer, the switches can vibrate on and off of each other a little bit, even the contacts.
And enough for, current to flow and not flow multiple times per key press. And so that's what bouncing is. And that's what software and more often firmware is correcting for.
Yeah, typically I looked on the firmware for my like control drop, and when you compile it yourself rather than using one of the precompiled binaries that they ship, then you can actually change the debounce settings in the firmware.
The newer firmware I put on this Keychron also exposed a debounce setting, and I think it's at like 5 milliseconds by default right now, which has basically fixed everything.
Oh, that's good. Yeah.
Although it did lead me to ask, since we're talking about this situation, it did make me wonder, where is the debouncing happening? Like, obviously it's happening in firmware because we're talking about that and we can see the setting exposed for it, but it also made me wonder if the software receiving the input is doing any debouncing.
Probably not.
Whether OS. Also, what I looked up is that yes, and in most cases on operating systems, they have to account for a wide range of input devices, not just highly precise gamer keyboards. So probably most generic USB keyboard drivers in things like Windows and Linux are doing some amount of smoothing for that stuff. And the reason this came to mind is that I've been in my UEFI a lot lately, and I was seeing a lot more like double arrow key presses in the UEFI than I would ever see in Windows.
Is this after the update?
Yeah, this is in the last like week that I've been in there. Like I would be arrowing up and down through the menus and it would jump a little bit here and there.
Can you increase that debounce more, or is that a configurable option?
Yeah, I can tweak it more. But the point is, it seems like maybe the operating system does a little bit of its own smoothing on top of whatever's happening in hardware or firmware.
I mean, it's entirely possible. I mean, they remember, like, Windows has to account for everything from like terrible scissor keys on laptops to like dome keys to all sorts of other stuff. So,
well, there's going to be a generic keyboard driver that you're going through that's going to handle some of that stuff.
Yeah. So anyway, there's other stuff that's a side effect of these switches too, right? Like, Razer and Wooting both have magnetic keyboards that use features that are banned from use in Counter-Strike and Overwatch and games like that. The Razer has a thing called Snap Tap. I think Wooting calls it something tappy or tappy or something like that. And the idea is that when you flip that on, it only prioritizes your last hit input, so it releases the previous hits, which doesn't matter in a lot of games, but in a game like Counter-Strike where you have movement inertia and your gun accuracy is directly goes way bad the moment you gets better the moment you stop moving.
Mm-hmm.
Counter-Strike pros do a thing where they do cross inputs or opposite inputs called snapping. It's some simultaneous natural opposing or something. The idea is if you're pressing D to strafe right and you want to stop, then you don't just let off D, you also press A for a split second as you're letting off D. And it's something that getting the timing on is one of the things that separates Counter-Strike mortals from Counter-Strike gods, right?
Yes. Also, as with so much of what we talk about here, it all goes back to Quake.
It does.
Because remember the movement in Quake 1 and the amount of momentum you had when you let off the movements?
Well, and when you did diagonals, of course.
So, anyway, I can see why this might be a problem in the professional scene.
Yeah, so the feature that they added basically prioritizes your last used input, which means it removes any overlap between the key presses, which is one of the things you have to learn how to deal with on any new keyboard when you're playing Counter-Strike at a high level. And it only reports the last key that you press, even while another key is still pressed. So if you're strafing right,
you can effectively just interrupt your movement by hitting the opposing direction.
Exactly. And I'm gonna say I turned it on this keyboard. I fired up Counter-Strike. I immediately was able to stop and get like something I've never been able to do before. I was able to stop and get the perfect headshots with an AK, like tap, 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 no problem. It was wild. And that was after about 5 minutes of practice. So I understand why they've said, hey, don't use these. It seems like they're able to detect it in software, so they are issuing bans on using this kind of stuff. So don't do it.
Seems
like they're kicking you from games. It's not like a back ban.
Okay.
Basically, you get a message that says, hey, don't do that. Yeah, that's fine.
Yeah, like just preventing you from playing the game with the device seems fine. If it hit at the account level, that would maybe be a little much.
Yeah, and just to be clear, this is a thing you have to turn on in the firmware, in the software for the keyboard. Like I had to log into the software interface and flip it on. They call it speed tap in the ASUS software.
I wonder if they're using like kernel level detection features, because that seems like the kind of thing that would not be hard to spoof otherwise. You could like...
My guess is they're tracking timing.
They're all kind. Yeah, maybe that's what it is.
Also,
wait, but then you would start false positive catching people who are too good at this.
Well, my guess is that you don't do it in a precise. My guess is that the timing is always the same every time when you use the feature, and when a human does it, it varies by a couple milliseconds. I don't know. All I know is that don't use these features or you're going to get yelled at. It really, the games that I've seen that it referenced are for different reasons. Overwatch, you can do it to completely change your movement and make you move like you have some sort of weird powers or cheating. Actually, when you watch the videos of people using it in Overwatch, they literally look like they're cheating. It apparently doesn't matter in Valorant because the movement inertia isn't the same in Valorant. You stop almost immediately when you let off. And yeah, my understanding is that it's detected by heuristics, not by some sort of kernel level anti-cheat or something like that. So, and just to be clear, you can use the keyboard. You just have to turn the feature off.
And per their rules, you can still, as long as you've got that off. Yeah, it must be a detection thing then if you can still play with that feature disabled, but on that keyboard.
There's nothing fundamentally illegal about magnetic switches. It's the feature that lets you turn off. The other thing they do is they change the input at which the key stops reporting input, but that's a little bit less of an issue. Okay. I think that's everything. People use these sensors in like all sorts of Hall effect sensors are everywhere. Your fridge door likely has a Hall effect sensor. If it doesn't have a physical switch that turns the light on and off that you can see, if the light just turns on and off when it opens and turns off when it closes, that's almost certainly a magnet embedded in the door someplace. You can test it by getting a big magnet and running it around your fridge and seeing what happens. But the places we're mainly talking about are keyboards and mice. I've used Hall effect thumbsticks before, but not for any appreciable length of time. All of my gamepads that I use are still more or less stock. But yeah. I'm kind of curious about swapping out the TMR sticks. For some TMR sticks and Hall effect sticks. I did read a couple of comparisons. Like there was a person who did the TMR switch and basically put TMR sticks in one of his joysticks in one of his dual senses and Hall effect sticks in one of his dual senses, and then reported the differences. And the TLDR was they both seemed fine.
Yeah. It sounds like the differences would be imperceptible to a human, but like the less electricity and stuff is meaningful.
Yeah. And I think like this is one of those places where human perception is a spectrum, and like there's definitely going to be people out there that can tell the difference, but for the most part, probably they're functionally identical.
It is so fucking frustrating to me that none of the console makers have embraced at least Hall effects. Which sounds, if it's really that ubiquitous and commodified, yes, it probably would. I mean, of course, it would add a little bit of manufacturing cost, but as bad as stick drift particularly was on the Switch 1 and Sony's last couple of generations of controllers have also, I don't know how Xbox has been doing. I had drift on some of my 360 controllers, but...
So my 360 controllers, the problem I had with them wasn't drift. It was that the dead zone got wobbly. So it would kind of jitter even if you weren't touching the sticks. I actually haven't any problems with DualSenses.
I haven't either, but it's something you see a fair amount. I've never had a DualShock 4 or a DualSense, I don't think, develop drift, but I do. That's why the stick replacements are fairly common. You see people talk about it. But it's not as bad as Joy-Cons. Those are absolutely the worst. And I assume Nintendo just made the old Fight Club car crash recall versus settlement calculation. I think because you remember they started I think the policy was lifetime on the Switch 1, right? They would replace Joy-Cons with drift lifetime of the unit, not like 1 year warranty style. And I assume it's just the standard thing of, hey, it's still cheaper for us to just fulfill RMAs on the people who will bother to RMA than it is to take I don't know what it is, somewhere between like 50 cent to $3 extra cost per unit produced kind of thing.
It's it seems like on the Switch 2, they sealed them better, at least, so that you don't get as much dust and crap in there. But my guess is that the Hall effect sensors are significantly more expensive than the touchpad type sensors.
It's a bummer, though.
It's nice that the aftermarket controller, this is why you should buy an 8-bit DOE controller instead of that $80 Pro controller. So, okay, hands-on time. I've been testing the ROG Falcata, which is a split 75% gaming keyboard. It uses the specific kinds of switches like this. So one of the things that's important, just like in mechanical keyboard land, you have to match your switch with your keyboard. Most everybody uses the same standards for switches at this point. There are a handful of mechanical switches that are outside of like the Cherry MX 3 or 5 supporter snap-in plastic pieces and 2 connectors.
When you say standard, are you talking about physical form factor that would make them interchangeable in the same keyboard?
Yeah.
Okay. So you can just kind of buy any brand of switch? More
or less. There's like Cherry MX compatible switches, and then there's some other stuff like but we don't. The other stuff is relatively small. With this, you need to make sure that the keyboards match your switch because the magnet placement matters. Like the Asus keyboard and a couple others use magnets on the side of the capsule, and some of them use magnets on the center of the stem. Like it's all over the place. So like if you have a Wooting keyboard, you make sure you buy the Wooting magnetic switches. If you have an Asus keyboard, you make sure you buy the Asus one. If you have the Razer one, you buy the Razer one. Switch selection is dramatically lower than with mechanical keyboards because for obvious reasons. Yeah. Most everybody is shipping what are effectively linear switches. So no bump, no click for kind of obvious reasons, because the click is a mechanical process and the switch actuates at a configurable height. So like while you can move the actuation height, you'll never be able to move where that click happens. So you don't probably want to buy clicky switches for this until you figure out what height you want. And then maybe you find a clicky switch that aligns with the height that you like. I don't know. You can get clicky magnetic switches for other keyboards. I haven't actually tried them. I don't think I would want that, but I'm also a linear keyboard switch guy.
I like linears. I've actually, do people mix and match?
Sometimes people put different switches on their WASD and game keys.
I got this keyboard as a tactile because that's all they had in stock. I thought I'd never used one, so I had to guess at what I thought I would want, but I guessed that I would want linear, but they only had tactile at the time. So I bought the tactile keyboard and later bought some linear switches. But by then I have kind of decided that I liked tactile enough that I sort of mixed and matched. Like I think all my letter keys are linear currently and everything else is still a tactile.
Yeah, I like linear just because of noise. I like to be able to type a little bit while I'm on the microphone here.
Yeah.
But yeah, look, if I didn't do podcasts and didn't use my computer with the microphone on, I would have the clickiest, loudest, most obnoxious fucking switches you've ever heard.
Yeah. Yeah. There's a lot of things about one's computing habits that flow downstream of having to be on a microphone a lot.
Yeah, give me a big thonky, like I want something to sound like a Model 80, just thonk, thonk, thonk. So yeah, the switches, there's right now 2 switches on the market for this keyboard, so I haven't tried the other ones. They weren't in stock when I tried to get them.
What kind of pricing are we talking about on these?
Basically the same.
Yeah, I looked up. I look at Keychron just because that's what I have. Not that they're like the best or anything, but a full set of like 110 or whatever was like $30 for their Hall line.
So these are more in line with like a premium switch. When I looked at their, let's see, what is it called? The TTC golden magnetic switches. They were like $10, $8 for 10, I think.
10 switches
for 10 switches, which is like basically the same price I paid 10 years ago for my silent bobas on my control.
Now here's the bigger question. What is wearing out in these switches that necessitates more switches?
What do you mean?
Like, on the standard mechanical switches, it's pretty obvious why they would wear out over time.
Yeah.
Like what is wearing down in the magnetic switches? That
nothing.
Well, that's what I mean then. What are the scenarios in which you would need replacements is what I'm asking.
Oh, if you want like a stronger spring or a weaker spring, you want less travel distance or more travel distance, you want
so we're talking about buying switches that behave differently and not just switches to replace the old worn out switches.
Yeah, 100%.
Yeah, okay, so that's what I meant.
It's a personal preference, not a like the things to wear out are the physical mechanical interface of the plastic rubbing on the other plastic, and since they're usually pre-lubed, like they should last a really, really long time.
Right.
I guess the magnet could fall out. I don't know. It seems like the magnet's pretty embedded in there though. Yeah. So the weird thing about the switches,
it's like the switch industry in shambles here. Like this is the This is like the razor blade seller suddenly not being able to sell more razor blades, right?
I mean, kind of. The keyboards are a little bit more expensive generally than a comparable magnetic or mechanical keyboard. I think my assumption is that we'll see more preference come up and people will start making more like tactile and clicky switches.
Yeah, that makes sense.
The switches are really weird though, man, because when you look at the bottom of them, there's no conductors. There's no like contacts that go into the keyboard. It's just like 3 or 5 plastic pins, which is bizarre to me.
It's all invisible.
You
can't see electrons.
The keycap interface is the standard cross though, so you can use more or less whatever keycaps you want on it. It's louder than my control drop, but that is with the help of friend of the show, Nathan Edwards. I picked out some Silent U4 Boba Whites for that years ago, and they have been consistently the quietest key mechanical switches I've ever used. I believe there are quieter ones now. I don't think they make the Silent U4 Bobas anymore. But like it's a little funkier, it's a little clickier. Mainly when you bottom out the switches. Now, the weird thing about this keyboard is you don't have to bottom out the switches at all. Like you literally, you can just kind of graze your fingers across the top as if it's almost like playing a harp is what it feels like.
Well, that's configurable, right? You could
it's configurable, yeah.
To make you have to do that or close to it if you wanted.
Yeah, you can. So there's both this one has a knob on the side that lets you manually adjust the
cool.
activation height in software.
That's nice. Oh, wait. You still have to go into software. The knob just doesn't just do it on the fly?
The knob just does it.
Oh,
there's like a series of LEDs on the side, and you twist the knob and it goes up and down. So you can make it hair trigger or bottom out, depending on which one you want. It also has a web interface. So you go to the ASUS GearLink site and it connects to the USB HID. I looked to see what this spec is called. This is a thing that started. The first time I saw it was with the VIA firmware, the VIA QMK firmware programmer years ago.
Yeah.
But it like I've used some Fractal stuff. There's a Fractal headset that uses it now. There's a Fractal like fan hub and RGB controller that uses it now. A couple of ASUS devices use it. Like it's really nice to not have to have a bunch of software running on them. Like it's nice to not have to use G-Hub.
I think it's probably still a net good, both for not making you install a shitty software stack and also for being cross-platform. Presuming the like driver interface exists on other operating systems, you can do it on any of them. It's mildly concerning if, for example, that company were to go away one day, or even if the servers were down, like not being able to update your keyboard because their web-based configuration tool is suddenly unavailable is,
that sucks.
There are downsides here.
Yeah.
You would hope if they were going out of business, they would like release some local option for continuing to be able to support your device, but who knows?
Well, so you can also, like on this one at least, you can always use Armory Crate on Windows if you want. But once I added the UDEV rule that gave my browser access or my user access to the USB device, I was able to use the web tool on Linux with Chrome, no problem.
Yeah. So my Keychron has the same stuff. It uses QMK and has they have a web-based tool as well. I had to install some kind of open, is either keyboard or microcontroller driver stack. I forget what it's called.
It's a microcontroller driver stack, probably for Teensy or whatever's in those keyboards.
I just cannot remember the name of that open source project, but it supports like a bajillion keyboards. But I did have to install that to make the web interface talk to the keyboard. But
yeah, the thing that I don't know, I assume people know this. We talked about it on the mechanical keyboard episode, but like a modern mechanical keyboard can have more compute than like a computer that you had in the 90s, probably.
Yeah, totally. There's like I'd have to look at the specs, but I know what ARM CPU is in this keyboard.
Yeah, there's a bunch of like homebrew projects that just use Teensies, which are like relatively cheap microcontrollers that also have an insane amount of compute on them for what they are, for something that costs $10.
That's that whole thing of compute getting small and cheap and relatively powerful, a net good.
Yeah, like just to be clear, I don't think the math to do like it's not like an old dome plastic dome cap keyboard where the math on that is relatively simple. It's just closing circuits and measuring which circuits are closed and then sending the right signal to the motherboard. Like there's real math happening on interpreting the analog signals from the magnets and the Hall effect sensors and stuff like that.
And that enables things like extra profiles, different
Yeah.
Different layout configurations for different OSs and stuff like that.
Yeah, so this keyboard has multiple profiles. The interesting thing about actually using it is that it depending on where you set the actuation in the dead zone. So this lets you set activation point at a millimeter distance from the bottom, from the top of the key, the unpressed point, and you can set a dead zone where nothing happens, and you can set it on both the top and the bottom, and you can do it per key. So like you can have different settings on, say, your ASDF keys or ASDW keys than you do on your other typing keys. Or you mentioned profiles. It has on-device profiles, and you can switch between them. So you have different profiles for like hair trigger games and just using your computer for typing. I tried a bunch of different actuation points, and my initial thought was, I want this to be very near the top, because like it turns out the input latency on a keyboard is mostly in the travel distance of the key, right?
Sure.
So like if you're talking about, I want to have microsecond or millisecond accurate key presses, having to bottom out that key is a travel of a couple of millimeters, and that takes time.
Now this instantly brings me to the question of when are we going to start seeing switches with next to no travel on them? When
do that. They do low profile switches right now.
Yeah. Yeah. Well, yes. I mean, this is a low profile keyboard, but they still have a fair amount of travel. I'm talking like millimeters. Like when are Counter-Strike pros going to get to the point where they want like millimeters of travel on their keys?
Sub a millimeter. So the key travel on these keys is it's about 4 millimeters, I think. Okay. 3.5 millimeters.
Oh, okay.
Yeah. That's like how long the stem travel is on most Cherry style key switches.
Huh. Okay.
My guess is that what you'll do is set the keys to hit very near the top. I found that almost impossible because I kept triggering when I was just resting my fingers on the keyboard.
Right. Well, the other thing there though is that you still get and this is the Counter-Strike Pro problem. I would not care about this, but then you still have a variable amount of. You'd have to train your fingers to only press so far because you would be wasting time on travel. You don't need to activate the switch.
Well, that is 100%. Like that's a big part of using these when you set them to the hair trigger.
Right. That's where like just having a physical blocker in there to only have to depress the thing half a millimeter or whatever would come in.
I mean, I guess so it would be easy to take something and make a ring that goes around the stem that prevents it from going further than X amount. I don't know that anybody's done that yet, but that would be wild to see. I'd be curious about that.
I bet it's coming.
I'm sure you're not wrong. Did this make me better at playing games? Probably not. I don't feel like it.
Yeah.
Is it nice to be able to control the actuation height for the switches? Yes, absolutely. I find myself bottoming out a lot less when I'm typing fast. And my typing, I do have an occasional false positive where I hit a key just a little tiny bit too hard and it goes. But since that actuation depth is configurable, what I did was I started high and just kept moving it down until I stopped having a bunch of false positives, like a tenth of a millimeter at a time. And I ended up at like 1.5, 1.8 for typing keys. Space bar, I let bottom out.
Yeah, even if you never touch any of the configuration, like the actuation or activation height, I should say, or whatever, like this still seems like a net gain.
Yeah,
when you factor in that you probably never have to replace the switches, like they don't give out the way that mechanicals do and so forth.
I think probably that the keyboard will last, like by the time the keyboard is gross from being in close proximity to human, I'll be ready to do a new keyboard.
Just check it in the dishwasher.
Don't do that.
People used to do that.
I know, but
I'm joking.
Modern mechanical keyboard. This one has batteries in both sides.
Yes.
Yeah, that would be a bad idea. A couple other weird features on this that are kind of neat. You can because it's a split. It has screw mounts on the bottom, and you can tent it if you want. You can tilt. You can do a reverse tilt like the old Comfort Curve. I quite like it because I have it in like the normal traditional keyboard format when I'm typing, and then when I'm playing games. Then when I'm typing, I can angle it so I get a natural angle on the keys to type. So generally pretty good. That switch on the side you can use to alternate between a bunch of different things. It has like media controls. You can control the rapid trigger sensitivity, which that's a whole other feature we didn't talk about. but basically if you flip a switch on the front of the keyboard, it gives you the ability to like make the Typematic key press much, much faster, if that makes sense.
Mm-hmm.
So you just keeps typing really, really fast. So anyway, the keyboard's nice. I was kind of blown away by the keyboard. I was not expecting to be super impressed by it. I also want to talk about the new Logitech mouse. It's the Logitech SuperStrike X2. It's a G Pro mouse. It's basically the same shape as my old G Pro Superlight. It's Superlight 2. It's an ambidextrous shape, but only with thumb buttons for right-handers. Five buttons, I guess. Two regular buttons, the wheel that's clickable, and then 2 side buttons. And it uses their Lightspeed stuff for up to 8,000 refresh rates per second in Windows, unfortunately only. But what they've done is they put magnetic switches on the 2 main switch presses. So your 2 main mouse buttons are magnetic switches now, and they've added a haptic bouncer that's kind of like the thing in modern trackpads that aren't mechanically actuated now. And it's a little bit it gives you a lot of the same benefits as the keyboard, right? You can control the actuation height for the switches. So like I can set it so I just barely graze my finger on the mouse and it clicks. Yeah.
Mouse buttons are not something I think of as having much or any travel on them. They're kind of on off, but I guess it depends on the mouse.
There's travel, man. There's a little bit of travel. It's
not like a keyboard where you can really control, like it clicks or it doesn't, kind of. Like there might be a little bit of variation in there, but it's not quite the same thing.
Yeah, it's like if the keyboard is a 3.5 millimeter travel, this is a 0.5 millimeter travel on a mouse switch. I have one right here. I'm going to pull out.
And in fact, the feel of the mouse button is kind of what I was getting at with the super shallow eSports Pro keyboard switch, right?
You see that? I think it may be blurry, but
you get what I'm saying?
Yeah. Oh yeah. Yeah.
Like basically keyboard keys that feel like mouse buttons and how hard they need to be depressed, that kind of thing.
So you could make a keyboard with a bunch of these little tiny mouse buttons. I don't know how you get the keycaps on there. But there's a whole scene in the game in the high end mouse community. We've talked about the mouse review subreddit before, where people are swapping out their stock mouse switches with increasingly specialized switches that are either, like you said, really, really fast throw, really quiet, really like more loud, different actuation points, the whole thing. And this gives you, again, a software configurable version of that experience. Unfortunately, with this, you have to do it all in the G Pro software. The big thing is that it turns out you need the haptic input on the mouse to know when you've clicked. Because otherwise, the switches are so small and the travel distance is so short that without that click, you don't know that you've clicked.
You build in like a mechanical click mechanism.
Well, so that's what the haptic thing is.
Well, no, that's what I mean. I ask because on this G502X it uses, I think, what they refer to as mechanical optical. Like they're optical in terms of signal sensing.
Yeah.
But I believe they just built a mechanical clicking mechanism in just to make them click.
That would make sense.
But they didn't do that here for whatever reason.
Well, they have the haptic thing in place of that. So if you have the mechanical switch, you couldn't adjust the haptic. Like you'd still get the mechanical even with the haptic. So the haptics, I've had it for 3 or 4 days at this point. I'm not sure how I feel about the haptics. The haptics feel really mushy compared to, if you think about how a mouse click feels, like I'm going to hold up to the microphone and you can kind of hear it. Like there's an immediate, you know exactly where it actuates, or you know exactly where the click happens because you feel it and hear it. And with the haptics, you can't hear it at all. It's very, very quiet, which I do like. But the actuation point feels less precise than with a traditional mouse switch. I think my hope is the haptics should be software configurable, so you can have like different, like if you think about how a Joy-Con works, or the trigger rumble on a DualSense joystick, a gamepad works. There's a lot of variability in how you can present the sound waves that turn into those haptic bumps on those devices. And my hope is that they'll get to a point where they let you configure what those curves look like. So it's less of a hump and more of a square wave type look. So it's on, off, and is very precise and very, very sharp feeling. But the software is not there for that yet. You can configure, like I said, you can configure the actuation depth, so you can make it so you bottom out the press, or you just barely graze. And I actually quite like that. I've been playing a lot of Arc Raiders lately, and I've been playing a lot of guns that are semi-auto guns. And even in like Fortnite, where a lot of the guns are full auto, but you're meant to, if you're good at the game, be tapping the shots. It's remarkable how much more accurate I am with the really light touch on the switch to do the triggering. Like you can make it so you just barely graze, almost like it's a touch surface, which is kind of wild to me. And it has, if you're in Windows and you're running G-Hub, you can change the profiles on the fly based on the game you're playing. I generally, on mice especially, advocate setting and forgetting your settings so that you're locked in, because you want your brain to inherently know that moving the mouse this much is going to make you turn this much no matter what game you're playing. And it's better to kind of normalize across, normalize like one DPI, one set of settings. But
yeah, have you used the onboard memory manager with this one?
I have. Yeah, it's the same it's the same as it always is. Yeah, because I'm using it right now in Linux.
Yeah, that's do they make that for Linux?
No, I'm using the onboard. The old onboard memory manager. No.
That's what I use instead of G-Hub, to be clear, because that's just a lighter weight way to manage the mouse profiles and sensitivity and stuff.
So they only gave me the mouse is just out as we're recording this now.
Oh, okay.
So I'm using pre-release software, and they only gave me G-Hub. I don't know if the onboard memory manager does, but I am using the onboard memory profiles to set up how I want it to work in Linux. I do still wish that this had a profile button on the bottom so that I didn't have to bind a key on the mouse to changing profiles. The next thing to do is I have like 3 different kinds of mouse switches here that I want to do some testing with. I have some old KLH Reds, which were the kind of default, you want to change your mouse switches the last time I went through this process. I also got these brown, I can't remember what they're called. They're brown with yellow bumps, and they're supposed to be the standard for quiet switches these days. Relatively hair trigger. And I'm going to try both of those and some other mouses that I have and compare them to this for upcoming PC World stuff. But yeah, like it's interesting. The whole thing about this is interesting because we talked about the optical mouse sensors last year or the year before as being a really impactful piece of technology, because they turned something that was a physical sensor. In the case of mice, it was wheels with slots cut into them that they could shine light through that were attached to rollers that rolled when you moved the mouse ball. And that was how we moved cursors up until the late 90s. Then the optical sensor came on and turned that into a silicon-based process where we got all the benefits of camera technology improving and silicon getting faster. And that gave us things like mice that are 32,000 DPI or something ridiculous, which, just to be clear, unless you have an insanely high resolution screen, a 32,000 DPI mouse is kind of crazy. But an 8,000 DPI mouse makes a ton of sense. I'm using like 4,000 DPI pretty much all the time on my mouse to get really smooth movement across my 4K displays, right?
Yeah, I'm at 3,800. It's nice. Also, crucially, you don't have to clean them.
Yeah.
Which kind of ties into the thing with mechanical keyboard switches versus Hall effect or TMR or whatever. Like remember how often you had to turn over your ball mouse and take the ball out and clean all the lint out
and clean the ball and get the gunk that was stuck on the rollers. But it also, because moving stuff to software has traditionally been really good for giving you more control over it. Now, the tactile stuff, I'm really curious how this ends up working. Like, I don't think this tactile solution that they have in this Logitech mouse is ever going to replace like the feel of a mechanical interaction in a clicky switch or a tactile
Maybe
switch.
Not, but it's also possible that their haptic implementation is just not up to snuff yet, because like I think about the trackpad on current MacBook Pros.
That's true.
And that is basically good enough to fool your brain into thinking that like I still to this day am shocked there's no mechanical actuation going on when I press on that touchpad, because it feels indistinguishable from back when they did use mechanical touchpads 15 plus years ago.
It's 12 years since they switched to the haptic one, as I recall. And yeah, you're absolutely right. Like that is indistinguishable from the old way of doing it. Now, the weird thing about that is they haven't really done it for anything except for mimicking that old old physical behavior, right?
So maybe we'll get into this soon, but I don't know about the previous AirPods, but the new AirPod Pros also feel basically like I'm pressing a real switch, but they have a little scooped and indented.
Oh yeah, the twos do that too.
Touch area that actually feels like a switch you're pressing, but they also kind of convincingly feel like you're pushing a button.
Bump.
Yeah.
Well, yeah. So anyway, that's kind of it. I'm curious to see what. Like, I don't think these are going to replace mechanical switches and everything because there's more cost, frankly.
Yeah.
So this is going to be an upgrade forever, I think, probably.
I guess in some contexts it makes sense for these to be a premium option. But again, with like the default controllers on consoles, it would be a real bummer if they never adopt this just because of the parts wearing out. I mean, those controllers have gotten very expensive. For like the default first party ones, to be clear. Like the new Joy-Cons are $100.
It's wild to me. Even before tariffs, the Switch 2 Pro controller was $80.
Yeah.
And like I feel
DualSense also about $70, $80 depending on color
$70
and stuff.
I think, yeah.
Like that's pretty expensive for something that wears out that aggressively.
I also, I mean, especially when they're selling premium controllers and those premium controllers aren't using the fancy sticks either. I'm curious about why that doesn't happen.
Yeah. And on the flip side, a lot of the 8-bit do controllers that do use Hall and NTMR are cheaper than those.
Yeah, well, who knows? I mean, look, this is the first time in my life that the third-party controllers have consistently been better than the first-party controllers.
Yeah.
Because like if you think about, I think about going over to a friend's house in the N64 PlayStation era, and I saw that they had a bunch of weird color controllers that they bought at Walmart, and I was like, oh man, this is gonna be a bad time. And these days, if I go someplace and I see 8-bit do controllers, I'm stoked. So
yeah.
I'm curious to see how people continue to use these is I guess the kind of TLDR. And I don't think like this Falcata keyboard is nice. They have a regular non-split version as well that also uses the magnetic switches. I think if I were buying one of these, I would buy one of the ones that's a little bit more user configurable because I wouldn't mind having more access to the firmware, even at the expense of like the keyboard configuration interface being pretty nice on this and using the web thing. To your point earlier, I think I started to talk about this. You can still, in addition to using the web interface on Windows, they have a mouse companion that lets you do things like change the profile based on the application that's running. Because obviously the web-based interface can't do that. It also notifies you if there's a software update, or you can just configure it using their main ASUS gamer software. What is it called? God, I'm completely blanking. It's the thing that you use to control the lights on your motherboard too, if you don't use OpenRGB or something like that. Armory Crate.
Oh, I started to say Armory Crate. I mean, that's the thing that pulls like motherboard drivers and stuff. I didn't realize that was also their gamer utility.
So that controls fan speeds, lights. Like if you have a ASUS AIO, it controls that. If you have, you can do firmware updates and everything. It's basically like they're all in one. I think it's not great software. I don't generally run it on my computers if I can avoid it.
Yep.
But that is your option if the web interface goes away, right? Is to get an old version of Armory Crate that still supports your device. And yeah, I'd love to know what you all think about this stuff. I'm curious. Like I was curious just to try it because I hadn't used any of these switches before and was curious to see if, software is better than hardware.
Yeah. It's cool to see stuff advance.
Yeah. Good technology, not bad technology. That's it for us this week, I guess. As always, this is a listener-funded podcast. We wouldn't be here without you guys, the listeners. So if you would like to support the show and make sure that we keep doing this, you can go to patreon.com/techpod. Again, it's patreon.com/techpod, where for $5 a month, you get access to the fabulous TechPod Discord, which is full of beautiful nerds just like you, as well as the monthly patron exclusive episodes where Brad and I talk about ongoing projects. And sometimes we take extra questions if we have a bunch of good questions one month. Small topics that don't fit into a normal episode that are maybe too small to talk about in a normal episode. I think we initially thought that this might be one of those, this mechanical keyboards, magnetic keyboards rather.
No, there's plenty of meat here.
And then, yeah, it ended up being really interesting when we kind of dug in a little bit. So you can go again to patreon.com/techpod to sign up. It's $5. We appreciate each and every person who supports the show. But we especially appreciate our executive producer tier patrons, including Jason Lee, Enwi Felicitas Rips, Andrew Slosky, Jordan Lippett, Fiends 1 through 4, David Allen, James Kamek, and Pantheon, makers of the HS3 high-speed 3D printer. Thank you all so much.
Thank you.
That'll do it for us this week. We'll be back next week with another edition of the Tech Pod. Until then, please consider the environment before printing this podcast.